We as humans, we're a curious bunch, aren't we? Always poking around asking questions. Why is the sky blue? What makes a rainbow? Is there anybody out there? That last one, that's a big one. It's a question that's haunted us for centuries, staring up at the stars, wondering if we're alone in this vast cosmic expanse. For a long time, we thought our solar system was the be-all and end-all. A nice, orderly collection of planets, all neatly orbiting our sun. But in 1995, everything changed. Two Swiss astronomers, Mayer and Queiroz, discovered the first exoplanet orbiting a sun-like star, 51 Pegasi b. It was a gas giant, bigger than Jupiter, orbiting closer than Mercury orbits our sun. Finding a planet hundreds of light-years away is like finding a needle in a cosmic haystack. But these astronomers used the radial velocity method, looking for the tiny gravitational tug a planet exerts on its star. Since then, thousands of exoplanets have been discovered. Hot Jupiters, super-Earths, mini Neptunes. We've got a whole cosmic zoo of planets out there. And it's only getting bigger. So, what does all of this mean? Why should we care about planets orbiting stars light-years away? Well, for starters, it means we're not alone. It means that our little corner of the universe is just a tiny fraction of what's out there. But it's also incredibly exciting. Every one of those exoplanets is a potential world, with its own unique history, its own geology, maybe even its own life. Now, I'm not saying we're going to be shaking hands with little green men anytime soon. But the fact that these planets exist at all, it changes everything. It makes the universe a more interesting, more mysterious, and frankly, a more hopeful place. Alright, space fans, so how do we find these elusive exoplanets? It's not like we can just point our telescopes at a star and say, aha, there's one. But fear not, intrepid explorers. Astronomers have devised ingenious methods for sniffing out these hidden worlds. They've turned the tables on the universe using the very laws of physics to reveal the secrets lurking light-years away. Imagine, if you will, a cosmic dance. Stars and planets, locked in a gravitational embrace, twirling around their common center of mass. And it's this wobble, my friends, that gives the game away. One way astronomers detect this wobble is through the radial velocity method, or what I like to call the stellar jitterbug. As the star moves slightly towards us and then away from us, due to the planet's gravitational pull, the light it emits gets stretched and compressed. This causes a subtle shift in the star's light spectrum, like a cosmic Doppler effect. By analyzing these shifts, astronomers can determine the presence of an unseen planet, its mass, and even its orbital period. Another clever trick is the transit method. When a planet passes directly between us and the star, it blocks a tiny fraction of its light. It's like a mini eclipse, a cosmic wink that betrays the presence of an exoplanet. Now I know what you're thinking, Neil, this all sounds pretty complicated. Back in the early days of exoplanet hunting, there was this one case, a real head-scratcher. They found a planet, a big one, orbiting a star called HD 114762. But the planet's orbit was incredibly eccentric, like a cosmic roller coaster ride. It was so strange that some astronomers thought their instruments must be malfunctioning. But the data was clear. This planet was a cosmic rebel, defying the neat circular orbits we were used to seeing. The hunt for hidden worlds is a cosmic game of hide and seek, with astronomers using every trick in the book to uncover the secrets of these distant planets. Now that we've got a handle on how we find these exoplanets, let's talk about the stars of the show, the planets themselves. And believe me, they are a diverse bunch. Forget everything you thought you knew about planets based on our little solar system. Out there in the vastness of space, things get seriously weird. We're talking planets hotter than some stars, planets with diamond rain, and planets that make our gas giants look like puny marbles. First up, we've got the hot Jupiters. Imagine a gas giant bigger than Jupiter, but orbiting its star closer than Mercury orbits our sun. These planets are scorching hot, with temperatures reaching thousands of degrees. Then there are the super-Earths. Planets larger than Earth, but smaller than Neptune. Some might have thick atmospheres, while others could be water worlds, completely covered in oceans. And let's not forget the oddballs, the planets that defy categorization. The universe, my friends, is a stranger place than we could have ever imagined. Section 2, Hot Jupiters Up Close and Personal. Let's take a closer look at these hot Jupiters, shall we? They were the first type of exoplanet discovered, and they certainly made a grand entrance. These planets are thought to form much farther out in their systems, like our own gas giants, and then migrate inwards over time. But the real kicker with hot Jupiters is their atmosphere. Because they're so close to their stars, their upper layers are constantly being blasted with intense radiation. Some hot Jupiters even have tails, like giant cosmic comets, as their atmospheres are slowly stripped away by the stellar wind. Section 3. Super-Earths bigger, denser, and full of mysteries. Now, let's move on to the super-Earths. Those intriguing planets that straddle the line between rocky worlds and gas giants. They're bigger and more massive than Earth, but smaller and less massive than Neptune. Some super-Earths are thought to be rocky planets with thick atmospheres, like a super-sized Venus. Others might be covered in vast oceans, perhaps hundreds of kilometers deep, with exotic forms of life lurking in their depths. The exciting thing about super-Earths is that some of them reside in the habitable zone of their stars, the region where temperatures are just right for liquid water to exist on the surface. So, if we're looking for signs of alien life beyond Earth, super-Earths are definitely a good place to start. Section 4, Kepler-186f, a distant cousin in the habitable zone. Speaking of potentially habitable planets, let's talk about Kepler-186f for a moment. This planet, discovered by the Kepler Space Telescope, is a true gem. It's about 10% larger than Earth and orbits a red dwarf star, cooler and smaller than our Sun, about 500 light-years away. Kepler-186f orbits its star within the habitable zone. That means if conditions are right, liquid water could exist on its surface. Of course, we don't know for sure what Kepler-186f is like, but the possibility of another Earth-like planet out there is enough to keep us searching. Section 5. The Diamond Planet blinging out the cosmos. Alright folks, get ready for this one because it's truly out of this world. There's a planet out there called 55 Cancri e that's believed to be made largely of pure crystallized carbon. 55 Cancri e is twice the size of Earth but 8 times as massive, and it orbits its star in a blistering 18 hours. Because of the intense pressure and heat deep inside this planet, scientists believe that the carbon atoms have bonded together to form a giant diamond. We're talking a diamond twice the size of Earth. Of course, getting our hands on this cosmic bling might be a tad difficult, but hey, a space enthusiast can dream, right? Section 1. The next generation of exoplanet hunters. Hold on to your hats, space enthusiasts, because the future of exoplanet exploration is looking brighter than a supernova. The next generation of telescopes and spacecraft are poised to revolutionize our understanding of these alien worlds. Take the James Webb Space Telescope, for example. This magnificent piece of engineering is already sending back jaw-dropping images from the early universe. But the JWST is also a powerful tool for studying exoplanets, analyzing the light passing through an exoplanet's atmosphere. With each new telescope, each new spacecraft, we're pushing the boundaries of what's possible, getting closer to answering that age-old question, are we alone in the universe? The search for life beyond Earth. Is there life beyond Earth? It's a question that has captivated humanity for centuries. With the discovery of exoplanets, it's become more tantalizing than ever. We're talking about any form of life, from single-celled organisms to complex ecosystems. Perhaps even intelligent beings looking out at the cosmos just like us. One way to find it is to look for biosignatures, chemical fingerprints that life leaves behind. Scientists are developing sophisticated techniques to tease out the faintest signals of life. Section 3. Cosmic roadblocks and funding fiascos. Now, I hate to be a downer, but the path to cosmic discovery isn't always smooth sailing. Sometimes it feels more like navigating an asteroid field, with bureaucratic red tape, funding shortfalls, and the occasional exploding rocket thrown in for good measure. Take funding, for example. It's tough enough convincing Congress to fund basic research here on Earth, let alone missions to distant planets. You try explaining to a politician why we need a $1 billion telescope to look for water vapor on a planet they can't even pronounce, And then there are the technical challenges. Building a telescope that can see a planet trillions of miles away is no walk in the park. It's like trying to build a car engine out of toothpicks and chewing gum. Impressive in theory, but good luck getting it to run smoothly. But hey, that's what makes it exciting. Overcoming these challenges, pushing the boundaries of human ingenuity and technology, that's what exploration is all about. And when we do make that groundbreaking discovery, that first glimpse of an alien world teeming with life, it will all be worth it. Section 4. A universe of possibilities awaits. So there you have it, folks. The search for exoplanets is a cosmic adventure full of wonder, mystery, and the occasional bureaucratic headache. But it's a journey worth taking, for it holds the potential to change our understanding of the universe and our place within it. Imagine the possibilities. Discovering life beyond Earth would be the most profound scientific discovery in human history, proving that we are not alone in the vastness of space. It would force us to rethink our place in the cosmic order, to confront the awe-inspiring diversity of life that might exist out there. And who knows what else we might find? New technologies, new resources, maybe even new friends among the stars. The universe is a vast and mysterious place, and we've only just begun to explore its wonders. So, keep looking up, keep asking questions, and never stop exploring. The future of exoplanet exploration is bright, and the universe is waiting to be discovered. Section 1. The Cosmic Mirror. So, we've journeyed far, haven't we? From our pale blue dot, we've cast our gaze across the cosmic ocean to these distant, mysterious exoplanets. Worlds that stretch our imagination, challenge our assumptions, and make us question everything we thought we knew about planets and the possibility of life beyond Earth. But perhaps the most profound aspect of this cosmic quest isn't what we discover out there, but what it reflects back at us, right here on Earth. You see, exploring the universe isn't just about finding new worlds. It's about understanding our own. Every exoplanet we discover, every scorching hot Jupiter, every enigmatic super-Earth, every diamond planet sparkling in the cosmic void, it's a chance to step outside our own limited perspective and see our own planet, our own solar system, in a new light. It's a reminder that we are part of something much grander, much more awe-inspiring than we can sometimes comprehend. That our pale blue dot, for all its flaws and imperfections, is a precious oasis in the vast cosmic desert, a testament to the extraordinary power of life to arise and flourish against all odds. A universe of wonder, think about it. Before exoplanets, our solar system was the gold standard. 8 planets, a cosmic ballet for billions of years. But then the universe threw us a curveball. Hot Jupiters, gas giants defying expectations, super-Earths hinting at countless habitable worlds, the sheer diversity of exoplanetary systems. The universe whispers, keep looking, keep exploring. Section 3. The importance of knowing. Why does it matter? Why care about planets light years away? We've got climate change, poverty, political unrest. Why spend billions on alien life when we struggle here? Exploring the universe helps find solutions. It pushes human knowledge and inspires future generations. Technologies for space improve medical imaging, develop efficient solar panels, and monitor our planet's health. Most importantly, it satisfies our innate curiosity. We are explorers, driven by a thirst for knowledge. Section 4. Keep looking up. So as we stand on the cusp of this new era of cosmic exploration, let us embrace the unknown with open minds and a sense of adventure. Let us marvel at the strange and wonderful worlds that await our discovery, and let us never lose sight of the profound impact that these discoveries have on our understanding of ourselves and our place in the universe. The universe is a vast and mysterious place, full of wonders yet to be revealed, so keep looking up, keep asking questions, and never stop exploring. For in the words of the great Carl Sagan, somewhere, something incredible is waiting to be known. And who knows? Maybe one day we'll find that we're not alone in this vast cosmic ocean. Maybe we'll discover life on a distant planet, or receive a message from an intelligent civilization light years away. Until then, let us keep our eyes on the stars, our hearts filled with wonder, and our minds open to the infinite possibilities that await us in the great cosmic beyond. The journey of exploration has just begun.